Hi everyone, in this video we are going to learn how to create the very basic Hello World program making use of FreeRTOS, and the code which we are using for learning FreeRTOS is ESP32. Okay, so talking about the first thing, so by the way, how to create this project and how to reach at the stage and which tool we are using for the development, there's a separate video for that. We are using platform IO. We're not using the ESP-IDF development framework directly, but the code is using it inside the platform IO environment. Okay, so talking about the very first thing, talking about the include. So the very first include header is stdio. This stdio is basically standard input output library. The printf function basically is being declared in this library. That's why I have included that. Talking about the second include. So second includes basically for the hardware configurations of ESP32. So this is the file which is being generated by the menu config of the ESP32. We are going to get into details of that later on, but for learning about or focusing on the FreeRTOS, there's not much need of that. Talking about what this header is about, so this is about the hardware configurations of this particular board to work in work perfectly. Talking about the second and the third headers. So basically, if you talk about this one, this task.h. So if you talk about FreeRTOS is a very tiny operating system. It consists of only three files: the task file, the queue file, and there's the third one. I don't remember its name exactly. So this tasks comes out of that. So FreeRTOS slash task is basically the header of the original FreeRTOS source code, and this one is basically contains the details of the ported version of FreeRTOS for this particular board. So for writing any code that makes use of FreeRTOS for ESP32, you need to include these two headers. Talking about the last one, this is related to the hardware related details of the ESP32 board. So again, this is for configuring the hardware. This is for some other parameters of the hardware, right? So if you talk about this particular definition, I got this definition from this header. Okay, so talking about what is a function, what is a task? By the way, task is actually nothing more. It's just a simple C function, a C function that never returns. That's it. Nothing more, nothing less. So what's the benefit of a task? A task's benefit is that it runs in concurrency with other tasks. So it's like you segregate your application to different chunks, and one chunk that does a particular job is actually a task. So as it's nothing special, it's just a C function, we declared a void type function. Why void type? Because it's never returning function. Okay. So here we have the parameter. For this particular video, we are not going to pass any parameter, but you may keep it void. Okay, so to make it never returning one, we add an infinite loop, right? And that's what you're always going to find in FreeRTOS code. In this, I write a printf that is saying hello world. And then we are making a call to a FreeRTOS function that's called vTaskDelay. This vTask delay is actually the delay that is going to be added here. Basically, your task is going to be shift to halt state for this particular milliseconds, right? Okay, why to divide this by this particular parameter? So basically, this is just to ensure the reliability, right? If you don't do this, still it's going to work, but to ensure that this code works the way you intended to work on your hardware, you should always divide it by this parameter that is related to the ticks, or you may say the clock speed of the board. Coming to the main application, so the flow of the main code starts from here. Here we create one task. How to do that is, you make a function called create task. So if we go to the documentation, the FreeRTOS manual reference manual is available here, where it is at FreeRTOS or the slash documentation slash FreeRTOS underscore books.html, or under support here in books and manuals. You go here and come here. This is a very good resource, and the official and the only official resource to follow FreeRTOS. You write x create, right? So let's go to task create. Yeah. So by the way, there are more than one functions to create tasks, but you will hardly find any other being used other than this X task create. Okay, they are actually the variants of these two. The first one, which we may cover in some video. Okay, so what is the first parameter of it? The first parameter basically is the reference to the function which you are converting into a task. So basically, it's simply just the name of the function. Okay, so if we talk about what we did here is we wrote the name of our function, that is hello world. Okay, talking about the second one. Second parameter is basically the easy to understand string or name of that function. So what did we did it, we just wrote hello. The third is the stack size. Okay, this is the stack size which you want to allocate to your task. The next are basically the parameters which you want to pass to your task, which we are going to do in some other future video. Okay, if you don't have anything to pass to the task, you simply keep that null. The next parameter is very important one, that is called the priority. So FreeRTOS, as the name suggests, it's RTOS, it's a real-time operating system. So different tasks have different priorities. Some of the tasks are higher priority tasks, some of the tasks are lower priority tasks, right? So the number of the priority starts from 0, be specifying the very low priority task, and the maximum supported priority or the highest priority is being defined by you in the configurations, and that is being that is equals to config max priority minus 1. Okay, we keep it 1 for the time being. The last is the task handler. So task handler is a pointer, right? It can be used for various things like deleting the task, etc. But for this video, we are not making use of it. So what it says is px task created task can be used to pass out the handles to the task being created. This handle can then be used to reference the task in API calls that, for example, change the task priority, delete the task, etc., as I mentioned previously. So we are not making use of right now, so we specify it to be null. Okay, now I'm going to plug my ESP to the computer and upload this code. So the intention is that this code is going to print hello world after 1 second, every 1 second. Click the upload button and then hold the boot button on your ESP port and wait for the code to be loaded. It's uploading. Now you may release the button. You open the monitor, serial monitor, and reboot firmware. So here we can see we are getting hello world being printed after 1 second. That is it for this video. In the next video, we're going to learn how to delete a task. And after that, we are going to learn how to pass parameters to the task. So stay tuned, do subscribe, and give me the feedback how I can improve my videos. Thank you very much.